Hello everyone, this is our first lecture for Chapter 6, Normal Probability Distributions. Here are the learning objectives for Chapter 6. This is what we are going to go over, and this is what you'll need to know for the next proctored quiz. Think of these learning objectives as your roadmap through the chapter and your study guide for the next quiz. Take a minute, hit the pause button, and read through these. In this lecture video, we will review the characteristics of the standard normal distribution and its relationship to z-scores. We will also introduce the standard normal table and how to determine probabilities for z-scores and determine z-scores that define a proportion. In previous lectures, we talked about normal curves and normal distributions. Remember that the normal curve shows where the scores are relative to other scores. The height of the curve shows how frequently those scores occur. The normal curve also shows us how many scores fall above and below the mean or other scores. It provides us a map to understand the relationship of any score relative to all the other scores in the distribution. It's really a great way to visualize the distribution. This is just a graphical representation of what we just reviewed. As you can see, this is the distribution for ACT scores. Most of the scores are near the center or the mean, and fewer scores are in the tails. The scores are understood in terms of relative position to the mean. Remember that most behavioral data approximate a normal distribution. Remember the characteristics of the normal curve or normal curves. They are: 1, normal curves are symmetric around their mean. 2, they have united central tendency. And 3, the areas under the curves are known. The total area is always equal to 1. Let's review the first characteristic of normal curves. They are symmetric around their mean. What does this mean? Well, the mean divides the distribution into two equal halves. The halves are mirror images of each other. If you fold a normal curve in half, both sides of the curve would overlap. This means that what happens on one side of the curve is the same that would happen on the other side. The second characteristic of normal curves is they have united central tendency. What does this mean? The mean, median, and mode are the same value. If you know one, then you know them all. The mean is also the most common or typical value in the distribution and is the 50% point of the distribution. It divides the distribution exactly in half, where 50% of the data will fall below the mean and 50% of the data will fall above the mean. The mean of normal distributions can equal any number from positive infinity to negative infinity. Remember, though, that the mean of the standard normal distribution is always equal to 0. The third characteristic of normal curves is that their areas are known. All normal curves are defined by their means and standard deviations. This figure shows the standard normal curve with its mean equal to 0 and its standard deviation equal to 1. The standard deviation divides areas into sections so that we can determine the area or probability under the curve at different points along the distribution. The total area under the normal curve is always equal to 1. The area under the curve has the same characteristics as probability. It varies between 0 and 1 and can never be negative. The standard normal curve is called the standard normal distribution, or z distribution, which has a mean of 0 and a standard deviation of 1. Scores on the x-axis in a standard normal distribution are called z-scores. Remember that z-scores can be created for any set of raw scores. This is what we mean when we say standardized scores. Z-scores tell us the exact location of a raw score from the mean in terms of standard deviations. For example, if I have a z-score of negative 1.46, I interpret this as this raw score is exactly 1.46 standard deviations below the mean. We use the z-distribution or the standard normal distribution to locate where a raw score would be. We also use the z-distribution or standard normal distribution to determine the probabilities of any raw score in relation to other scores. We can determine probabilities for observing scores greater than, less than, among the top or bottom percent, or the likelihood of scoring between a range of raw scores. The standard normal table, also known as the unit normal table or z-table, is a type of probability distribution table that gives us z-scores and their corresponding probabilities or proportions of area associated with each z-score listed. The standard normal table in the appendix of our textbook gives proportions of area under the standard normal curve for z-scores ranging from negative 3.49 to positive 3.49. Each z-score divides the curve into two areas, area to the left and to the right of the z-score. Area to the left of the z-score is given. Area to the right of the z-score is found using the complementary rule. Remember, probability of A prime, or the complement, is equal to 1 minus the probability of event A. Here is what the standard normal table looks like. The first column is always the z-score to the tenths, and the first row is the z-score's hundredths value. The table values correspond to area under the standard normal curve to the left of the z-score. The area is given in terms of proportions, which can be converted to percentages. The standard normal table can be used in two ways. One, to calculate a z-score and use that z-score to determine associated proportions. And two, use proportions to determine its associated z-score. Your textbook has a great video in Chapter 6 on how to calculate z-scores and find its corresponding proportions. The next video lecture will cover sampling distributions.